Okay. So we have 3 rules for finding a horizontal asymptote. And they're based on the degrees of the numerator and the denominator. Do you remember what we mean by the degree of a function? Like, what's the degree of the numerator here? It's 3, right? What's the degree of the denominator? 4. We're not looking for that word. You just say, what's the number, right? So the degree of the numerator is 3 and the degree of the denominator is 4, right? Whenever the degree of the numerator, which I'll use there P, the degree of P is less than the degree of Q, right? Then the horizontal asymptote is y equals 0. Always. Right? Just like we saw with the inverse variation, y equals k over x, it was always, the asymptote was right on the x-axis, y equals 0. Right? In the second example, right, the degree of the numerator is 3, the degree of the denominator is 2, so the numerator is a higher degree. So when the degree of the numerator, p, is greater than the degree of the denominator, q, no horizontal asymptote. There is none. The numerator is going to dominate the denominator, and it'll just grow without bound. Which leaves us with one possibility. What happens when they have the same degree? What happens when both of them are x squared? So degree of P equals degree of Q. Then the horizontal asymptote is y equals the ratio of the coefficients of the highest degree terms. Y equals 2 over 4. Or y equals 1/2. Right, those are the 3 rules. Now, there is another way around this, which honestly I think that maybe not only might it help, it might actually help in because we don't really know quite how they're going to ask the question. But let's say I wasn't sure on what's going to be the horizontal asymptote of this function. Then this is what if they gave you this and they said, what's the end behavior? The end behavior, right? Well, then you could go to the calculator, put that in the calculator. Y equals clear. Make sure we use the parentheses where needed. So in the numerator, that's 2x squared, 2x squared plus 3, end parenthesis, divided, parenthesis, 4x squared plus 3. And now go to the table of values and just start scrolling down the table of values and see what's going on with the y values. Does it look like they're converging to one number? Yeah, they're all 0.5. So that's the end behavior, 0.5. Okay. Yeah, well, this thing is goofy. You know, or you could just go into like second quit. If you went to your table set and second table set, and let's put it on independent to ask. Right? And then you go to the table and just put in some big number. You know, put in 1,000. 0.5. There you go. Y equals 0.5 must be it. That must be the end behavior. So we have our 3 rules, and they're really not very hard rules. But you also be able to put in the calculator. Just scroll down, see whether it looks like it's approaching a number.